Okay, so hello everyone, welcome. Can you hear me?
Yes.
Okay, thank you. Okay, just we're waiting 1 minute for joining all of others, then we'll start. In the meantime, I also give you an announcement for upcoming online training program. Basically, this training class will be start from 17 May 2024 and admission last day is the 15 May. So if you want to join this online training program for upcoming batch, you can simply contact in this WhatsApp number as well as you can also contact with this email. So basically, in this online training program, you will learn all of those things from beginners to advanced level. So that's why you can easily learn all of things. If we have no knowledge about the coding or if we have no knowledge about that programming, don't worry about that. You will learn all of those things from beginners to advanced level. So I already added all of those things in the video description. You can simply check it. And further, if you want to join, then simply contact with my WhatsApp number and also contact with my email. So as well as when you join this online training program, you can get some benefit such as you can get the course e-certificate after submitting all of assignment. You can get the all of course material, mainly slide, PDF. You can get all of practice code, recorded class, and lifetime teaching support. It's very important as a beginners, mainly when you want to learn the Google Earth Engine platform, you face a lot of problem. So that's why we're also providing the continuous support. So that's why you can easily learn the Google Earth Engine properly and you can easily apply it on your research work. So if you want to join our upcoming online training program, you can simply contact in WhatsApp number as well as you can also contact with this email. And our class will be start from the 17 May. So as soon as possible, get the 50% discount. You can simply contact and then make the registration. So now only 4 seats are available to get this 50% discount. So thank you. Okay, so now we'll start our today's session. So basically today is our last class, okay, and mainly today we try to discuss about that different types of topic. So let me share, and after that we also talk about the problem solving if you have any problem regarding this course. Not only for that, after completing for total 7 all of classes, when you face any problem regarding any issue, if you need any consult for any topic, you can simply join with me Google Meet. Okay, and before that you can simply contact with me before 1 day and take your time, and then you can easily get the solution and it continuously learning. Okay, you can get the continuously support for that learning, and just before 1 day you can simply knock me and get your time. Okay, so now we will start. So let me share my screen. Mm. So basically, today we talk about that mainly change detection, how we can easily perform the change detection in Google Earth Engine platform. It can be land use land cover change detection or NDVI change detection or any other indices. When you want to make the change detection, we also talk about that, as well as we also talk about that land use land cover classification change detection in one layer, mainly all of change. Suppose mainly transition area, suppose water convert into vegetation or water convert into build up area. So suppose or barren land convert into build up area. So this type of things how we can easily show in one layer in Google Earth Engine platform. We also talk about that, as well as we also talk about that hyperparameter training for improving the accuracy of our machine learning model. Okay, so let's go try to start one by one. Okay, so first of all, okay, I already write the code about that. So in this time, I just explain and then show you all of code. Then you can easily get this idea how it will work. So basically, you can see this is the code. I already discussed the full code, how we can easily make the land use land cover classification map and classify it. Okay, and in this time, we are applying that random forest classifier. And random forest classifier have a important argument. It's called that number of trees. Okay, but in this time we are just put here, suppose randomly put here the 63. Okay, but this 63 this 60, this number of trees is not perfect for this model. So that's why we need to find out a best number of trees, and it's called the hyperparameter tuning. Actually, which number provide you the best accuracy on your model, this number called the hyperparameter tuning. And in this time, when I put at the 60, then we just run the code and check the accuracy, what the accuracy I can got. I check it first, just simply run the code and then check the accuracy, and then I will try to find out that best number of trees which provide me the better accuracy. Suppose in this time, okay, here you can see we can get that 91% accuracy I got when I apply the 60, okay, as a number of trees. Then I can get the 91% accuracy about from this model. And now I want to apply that. I want to find out that hyperparameter tuning. Okay, so for doing these things in this time, what can I do? So first of all, I need to make a list. Suppose I don't know what's the number of trees is the best for my model. I don't know. For that, in this time, I just make a sequence. Suppose I just make a sequence. It will be start from the 20 and up to 400. Okay, start from 20 and up to 400, and I also define the interval 20. Suppose 20, 40, 60, then 80, then 100, then 120, then 140, and up to 400. Okay, just I make a sequence. It will be start from the 20 and up to 400. Basically, it's the number of trees. In this time, I am not put any kind of specific number. I want to put all of number. It will be start from the 20 and up to 400, and every interval 20. If you want to, you can also change it, no problem. Suppose you can start from that, suppose 10, and suppose you want to up to 300, and you can put the interval suppose 10. Okay, then what happened in this time? It will be start from the 10 and up to 300, and every interval will be 10. Suppose 10, 20, 30, 40, 50, and up to 300. Okay, so in this time it's depend on you. So in this time I want to choose, suppose I want to check all of number of trees value. It will be start from the 10 and up to 300, and every interval will be 10. Okay, or if you want to put the 20, it will be start from the 20 and up to 400, and every interval suppose 20. You can put any name. So in this time, I just simply take a variable number of tree list, and further I just put a EE list dot sequence. Okay, EE list dot sequence, and now when I just put this sequence, it will be start from the 10. Basically, it's our start value, in value, and it's our interval. So now what happened? You can see I just simply print that number of tree list. Suppose I just simply print that. So now it computing start from the 10, then up to 300, and like we find out every interval will be 10. So here you can see you can get that start from the 10 and interval and you can see and up to 300. Okay, and every interval we can see that 10 because I put here the 10. Okay, so now what happened in this time? I want to make a function. This function put is value, is number. Suppose 10, 20, 30, 40, 50, 60, 70, 80, and up to 300. Use all of number and calculate the accuracy. Okay, suppose when I put here the 10, what the accuracy I can got? When I put the 20, what the accuracy I can got? When I put the 30, what the accuracy I can got? And it's very difficult. Suppose you just put the randomly. Suppose you put the randomly 10, 20, 30, 40, 50, 60. It takes a lot of time. So that's why in this time we are using the concept of function. because using the function, lot of work we can done in a single code. Okay, so in this time we are just make a function. This function check all of number of trees value which start from 10 and up to 300, every interval 10, all of values, and then check accuracy at the same time. So that's how we can easily get it. Suppose when the 10, what's the accuracy, when the 20, what's the accuracy, when the 100, what's the accuracy, we can easily get it. So let's go. In this time we make a function, and this function, what is my argument? My argument is that I want to use all of numbers, mainly 10, 20, 30, 40, 50, 60, up to 300. I want to use all of number and I want to check the accuracy. Okay, so let's go. For that, in this time, after taking this type of number of list, I just make a list, all of number 10 to 300, and now I want to make a function, and this function I want to use and then calculate the accuracy. So for that, what can I do? You can see, just I write the function in here. So same function we try to put in here. Just take a variable accuracy. Just take a variable accuracy. Okay. And further, so this is my function. Okay. This is my function. And this is my collection. You can see number of trees. Basically, this number of tree list, it stored the all of number. Okay. And this is my function. This is my function. In this function, what I do? In this function, we are just take a element name, number of trees, and now I just put here the curly bracket. In this curly bracket, I put my argument. In this time, my argument is that I want to use the random forest algorithm, but not define the number of trees. Okay, you can see I am not put any kind of number of trees. Okay, in this time, all of number of trees come from this list 10, 20, 30. So that's why in this time I just take a variable number of trees and also put here the number of trees, element name, a number of trees. Okay, and further just put here that train function and use my 80% data train set which I already created, class property name class, input property is the parent. Okay, and what I return from here, I want to return from here, mainly I want to calculate the accuracy. So mainly for calculating the accuracy, we are just using the test set. Okay, where I already created, you can see the test set and train set we already created, test set and train set we already created in here. So in this time, I simply call the test set and connect with my model. Okay, in this time I put the model name is the classifier. You can see I already make the model name is that classifier, simply call in here. Basically this classifier, you can say I simply call this model name classifier. Okay, and further error matrix, class and classification, and further we try to check about the accuracy. So in this time, this is my function. Okay, in this function I don't define any number of trees, because in this time I want to check all of number of trees which start from 10 and up to 300, every interval 10, and it is stored in this variable. Okay, so for that, this is my function and this is my total collection, mainly total number of trees. So for connecting that, just use here the map function. Okay, simply call this variable name and use here the map function. So now this function which I created, it successfully connect with my collection, mainly it's my number of trees collection which I created in here. So now it stored the all of accuracies. Okay, so I again explain. First of all, you just make a list. Okay, simple list, start from the 10 up to 300, every interval 10. Okay, and further I want to use this type of number, basically 10, 20, 30, 40, 50, 60, all of number I want to use and then check the accuracy. So at the same time I want to apply all of number. So that's why I need to use the function. So for that, I simply create a function in here. So in this function, I take the element name, number of trees, and further I simply call I create a model. Okay, I create the random forest model and train with my 80% data set, basically which is stored at the train set, and then class property is the class, input property is the band, same approach. And what I return from here, I want to return the accuracy. So for that, I simply call the test set, classify with my model. In this time I create this model in here, but in this model you can see we are not put any kind of number of trees, because all of number of trees it's come from this variable. Okay, so that's why I simply call this variable name and then connect with the map function. Okay, so now it stored all of numbers and then check one by one. Okay, so in this time, for getting the more better visualization, in this time we are just make a chart. Suppose I want to make a chart. This chart help me. Suppose when 10, what the accuracy? When I put the 20, what the accuracy? When I put the 30, what the accuracy I can got? Okay, so it provide me all of values and their accuracy. For doing this thing, we are simply put the chart. Look like that. Here you can see. So just in this time, we are just take the chart, UI chart array values, and array mainly it's our accuracy, which I already created in here. The variable name you can see accuracy. Simply call this variable name accuracies and paste here. Okay, and X level, mainly X level show the all of number. Suppose X level show the 10, 20, 30, 40, 50 and up to 300 all of number. So further, when I just print that, suppose just simply print that, click to the run. Now it make a chart. In here. So here you can see we can get this type of chart. Basically, it's sure about that your random number of trees. Suppose you can see the when I put the 10 number of trees, I can get the 91% accuracy. You can see when I put at the 20, get the same accuracy. So 10, 20, 30, 40, 50, all of things it provide me the same accuracy. When I put the 140 number of trees value, I can get the 91% accuracy. Also, you can see when I put the 150, then I can get the 92% accuracy. Also, you can see when I put here the 300, I also get the same accuracy. Okay, so in this time you can see 150 and also you can see the 140. So in this time I find out the best accuracy 150. So this 150 is that hyperparameter turning, and all of number of trees we can get the same accuracy. Okay, so this all of number of trees when you want to use, you can get the same accuracy, and all of number it's called the hyperparameter turning because it provide me the best accuracy. If you want to check the other, suppose I just simply change it. Suppose it will be start from that suppose 20 and up to 400, and every interval suppose 20. Okay, now try to check again what happened. In this way it will be start from the 20 up to 400, every interval 20 we can get. You can say 20, 40, 60, 80. Okay, here you can see 160. Okay, 180. So in this time, this is my hyperparameter turning. From here, any one value I can use because it provides me the same accuracy all time. Okay? So in this time, when you can get this type of value for your model and you find out the best accuracy, basically which number or which number of trees provide you the best accuracy, you can simply use this value. Okay? So you can simply go to here and then simply put your model in here. In this time, you can see when I put here the 60, it show me the result is that 91%. Okay, but when I put here the value, suppose my another number of trees, suppose 160 or 180, we can get the 92% accuracy. Suppose I just put here the 180, and then click to run. In this time, you can check the accuracy. Suppose our accuracy will, you can see we can get the 92%. So it increase when I put the 180. Okay. So this is the process. Not only for that, all of argument. Suppose it's only for the one is random forest. Suppose you want to apply the classification. Suppose another algorithm. Suppose you can check. Suppose cart model. Suppose you can see the max node. Okay, you don't know what is the best max nodes value for your model. Okay, so basically you can see max node is the integer value. It can be 2, 4, 5, 10, 20, 60, 80, 90, 120. Okay, you can see the maximum number of leaf node in each tree. Okay, so in this time you don't know what is the best max node value for your model. So for that same process you have to use and then find out the best max node value. Okay, so I also give you some assignment regarding this topic. Okay, about that for the cart model, how we can easily find out the hyperparameter turning. So this type of things when you do, I hope you can easily get this better idea. And when you face any problem for doing your assignment, you can simply contact with me anytime. Okay, so in this time you also try, suppose you can see the max node. In this time you try to make a classification using this model. Okay, and this model you don't know what is the best max node value for your model. So just apply the same process. First of all, just simply make a list look like that, and then just make a function. Okay, and in this function, just in this time you can see number of trees I don't define because I got all of number of trees from this list. Okay, same process just apply also for this cart or any other algorithm. Suppose you can see the SVM or support vector machine. Here you can see, so here you can see the decision procedure. Okay, so basically in this time here you can see decision procedure for classification. It can be voting or merging. So basically it's one kind of, it's not any kind of your if you want you can also check it. Suppose for the voting what the accuracy you can got, for the margin what the accuracy you can got, you can easily check it from using the two default value. And default basically it's show about the voting, and you can see in it not used for the regression also. Okay, so this type of things about support vector machine you can also check it. Suppose one of CBS or one class or what provide you the best accuracy. Okay, or what kernel type. Okay, kernel type can be radial bias function, RBF or poly or one of linear. So your model, what argument or which key value is the best accuracy provide you. So just simply use this type of things and you try to check it. So basically this process is the same. Okay, so you also try to identify about the supervised machine or cart classifier. Okay, so then you can easily get this type of value, and which value provide you the best accuracy, just use this value on your model, then we also get the better accuracy. Okay, so in this time I give an example about that random forest, but this example is also same for other model when you want to use it. Okay, so anyone any question about that, you can ask me for that. Any question? For hyperparameter turning, basically it's provided with the best number of trees or best max node values, or any suppose who is provided with the best accuracy, which number provided with the best accuracy, we can find out these values. Okay, so I will send you this code. You also try to practice for the other model. Okay, so let's get this time other topic. So in this time we talk about that change detection, mainly land use land cover change detection. So basically here I already make a classification for my study area, look like that, and I want to classify it for the land use land cover classification map for 2 decades. One is that land use land cover map 1991 and 2021. Okay, and how I can make the classification, same process, so which I already show you that the previous class. So in this time you can see we are just classified the build up area, then forest or barren land and water body. Okay, we are just make the 2 decade land use land cover classification map, year of 2021 and 1991. So here you can see this is the map, first layer it show the map in 2021. So this is the scenario of the 2021. We find out that there are a lot of build up area. Red can identify about the build up area, yellow is the barren land, blue is the water body, and it's the forest or vegetation. Okay, so you can see this is the scenario about that we can get, and this is the scenario for 1981. You can see only for this area is the build up, but 2021 you can get that lot of barren land or lot of vegetation convert into the build up area. Okay, so this is the 2 decade land use land cover classification map. After creating these 2 things, how we can easily make the change detection in Google Earth Engine platform. Okay, so basically in this type, if you want, you can use the single change detection. Suppose you are just choose a one class and then you can make the change detection. Suppose I want to check only for that urban change detection. Okay, suppose urban growth, I want to monitor these things. So here you can see this is the urban place. Okay, so it is urban for 1991 and 2021 we find out this type of things in here. Okay, it increased the lot of area. So in this time, I will show you the both of process. Suppose single change detection and also multi-class change detection. Okay, both of things I will try to explain one by one. So let's go try to explain. So it's the same code. I also send you this code to try to practice more. You can get the more better. So basically, you can see first of all, we are just we are just simply put our study area. This is our study area. And further, we are just take the training sample. Okay, for the 2 decade. Okay. Suppose in this time you are just open the image for 1991. 1991 is just simply open the satellite imagery and take the training sample for water body, then build up, then vegetation, then others mainly barren land. Okay, we are just simply take this this type of class training sample from the satellite images using the different types of band combination. Okay, and also open the image of 1900 to 2021. I just simply open. And further, we are also take the training sample for build up area 2021, also 2000, also vegetation 2021, others. Okay, so all of class we also take for that 2021 also water you can see. Okay, and you can see just same process. When I just click on here, we can get that class 0. Okay, so 0 is for water. Also you can see about that build up 1, then 2, then 3. Okay, also you can see the water 2021, it's a 0. Okay, same sequence we put in here. Then also the 0, 1, 2, 3. So it's the 3. We can get the 3. Okay, so then further we are just applying the machine learning model, random forest, and then further we classify the 2 satellite imagery. We can get this type of result, LULC 2021, and also get the result for LULC 1991. So now these 2 map I want to check about their change detection and also calculate the transition area. Okay. For doing these things, first of all, you can see this is the full code about that classification. So basically, this is the code remove the cloud and haze from the satellite imagery. And also you can see this is the code for remove the cloud and haze from Landsat 8 satellite imagery. Okay. So basically, Landsat 457, this Landsat 457 is the same code for removing the cloud and haze. Okay. And but some difference for the Landsat 8. So that's why we create the 2 function. One function, this function mainly remove the cloud and haze from the Landsat 457, and this function remove the cloud from Landsat 8. Okay, and further we are just make the start year and end year. Okay, observation time, and we are just make the sequence about that. Here we find out the total 32. Okay, it start from the 1990 and 2021. Okay, 32 years satellite imagery we can create annual composite. Okay, annual median composite, and further. Okay, in this time we are not talking about the solve because it's the another part solve. Okay, so in this time, after creating these things, we can see all of band and band name. So B1, B2, all of band name for Landsat 5, Landsat 7, and Landsat 8. Okay, so you can see the difference between the band and band name for Landsat 5, 7. Basically, Landsat 5 and 7 is same. We can get some difference for the Landsat 8. For the Landsat 8, B2 is the blue, but Landsat 7 and Landsat 5, B1 is the blue. Okay. Also, you can see B3 is the green, but Landsat 5 and 7 is the B2 is the green. So for that, in this time, we are also provide the lens name. Okay, so you can see the all name is the same, blue, green. It is the same name. Also, you can see it's the same name. Also, you can see it's the same name. Okay, but you can see the band is the different for the Landsat 5, 7, and 8. Okay, it's the different. So that's but the band name is the same, blue, green, red, blue, green, red, blue, green, red is the same. Okay, so just we are make this type of things. Further, we are just filtering the Landsat 8 image collection, also Landsat 7, and further we also Landsat 5. Okay, then we are simply make the match all of Landsat 8, 7, 5, all of satellite image collection simply match, and we can get the total full collection. You can see full collection. You can get the 717 image collection. You can find out. Okay, so now this 770 image collection we convert into 32 years image collection. So for doing this thing, we are just put the code. You can see. So in this time, this is the function about that. So this is my when you convert. Suppose you have a image collection. This image collection you convert into others time period image collection. In this time I have total 717 image collection. I want to convert into 32 years image collection. So further I simply use the function e image collection from image. Okay, and I define the years. Years mainly I already defined the years. Years mainly you can say I already make the list of sequence of years. Here you can see the sequence about the years. Okay, so basically this variable stored the total 32 years start from the 1990 and 2021. It is stored in this variable. So for that I just simply input here that years. Okay, and I create a function. Basically in this time this function help me to create the median composite of each year. So further I simply call the full collection, because full collection 717. I simply put here the full collection and I want to filter it annually. So just put here the year and then I create the median composite and click with my study area. I return it as a year. So now we can print the annual image collection. We find out the total 32 years image collection in here. The 2 years we get in here. And further from here we are just simply visualize the image. Suppose I need the image 2021 or 2011. Okay, so for that I just take a variable and call my annual image collection. I want to filter it. I want to select year equal to 2021. Then I can get the 2021 image collection. Suppose year equal to 11. Then I can get the 2011 image collection. Okay, or 2001. Okay, so which year you want to need, you can simply filter. And further you want to visualize these things. So in this time we are doing these things. Here you can see it show all of images, but I want to work only for the two images. One image for 2021, another image for the 1991. Okay, so these two images I want to use, and further I want to make the classification. So for doing these things, just same process. We simply take the all of training sample, we simply merge. So we can see all of merge, we simply merge in here and store it the marks of 1991 and also all of sample is stored in the 2021. We are just simply merge. Okay, 2 year. And further we are just simply create the band. In this time we are just consider only for this type of band. If you want you can also add here the more band, suppose more external band, NDVI, NWI or any other band. Okay, so I already discussed about that how you can create with this band. But in this time we are just extract the pixel value or spectral signature only for the blue, green, red, near-infrared, short-infrared and pixel QA. Okay, and further we are just all of image we just simply connect with that, and further we are just simply use the sample return function and then we extract the all of make the data set. Okay, so then further we are just simply merge these two data set and then make the random column distribution. 70% data roughly we take and simply 70% data for testing, 70% data for training and 30% data for testing. Same process we do in here. And further we are just make the classifier. Okay, random forest classifier 150 we put the number please, and further just put the same process and also check the accuracy about that. Okay, same process. And further this model simply connect with that. Okay, suppose I call the image 1991 and select all of band, which band I want to use as an input and classify for connecting with my model. In this time my model name is the RF. So here you can see my model name is that RF. Okay, so this is my model stored at the random forest model. Okay, so further we are just classify and further we show the class about that land use land cover. We can get the two types of class 1991 and 2021. We can get the two land use land cover classification map. Okay, so now further after creating this land use land cover map, we are just check about that change detection between the two map, as well as we also add the code for that. You can see for exporting the land use land cover map in the as a TIFF format. Okay, for two time period. Okay, so in this time we talk about the single class, suppose urban change detection between the two time 1991 to 2021. Okay, for doing these things, first of all we are just make the single class of urban. Okay, suppose I want to calculate how much area are available for 2021. I want to check it. For doing this thing, just take a variable. I put the variable name, suppose build up area 2021. You can put any name, then equal sign and call my classification land use land cover classification map year of 2021. I simply call this variable. So here you can see I call this map. Okay, and this variable stored this map. You can simply check it from here. You can see this variable. Okay, so when I want to add map.addlet, then it show my map. So this variable is stored my full land use land cover map year of 2021. Okay, So just I simply call it, and then further I just put equal to 1. Equal to 1 means that in this time you can see the urban or build up area we set put here at the 1. Okay, so this is my value 1. So just I put here at the 1 equal to 1, and further we are just show the result. So just I apply the map.addLayer function and call this variable name in here, and I put at the mean 1, max mean 0, max 1. And where there is no urban, basically there is the, it show as a gray color, and where there is urban it show as a red color. And I want to put the layer name urban 2021. So now let's check only for the urban map 2021. Only urban class it show. Not net, just I comment. So now click the run. So now you can see it show about that only for the urban area. Okay, red color for urban area, and gray scale color it show the other class. Okay, so you can get only for the urban map year of 2021. If you want, you can also export this map as a TIFF format and show make a map in RPF software. Okay, so now I am to calculate how much area in urban for this region. So for doing these things, we are just use the same e.image.pixel area. Okay. So for doing this thing, just we have take a variable. I want to calculate the area, how much area for that. So take a new variable. I put the variable in suppose urban area, and call the build up area 2021 this variable because it is stored at the urban map. Okay, it is stored at the urban map. So I simply call and multiply with my function. Basically this function calculate the result in square meter. Okay, e.image.pixel area, it calculate the pixel area in square meter unit. So for that just I simply calculate the area. Okay, so for calculating the area we are just simply call this variable name. Okay, and I want to calculate the statistical total value of pixel area, total pixel area. So that's why we have to use the reduce region function. So we already used a lot of time for the reduce region function. Basically this function help you to calculate for any statistical value, median or average or standard deviation or total, it calculated for any specific boundary. In this time for this boundary I want to calculate the total area of buildup or urban. So that's why I simply call the urban area and then put the reduce region function and put here the total. Okay, this is my shapefile variable name AOI, and this is my scale 30 meter for Landsat imagery, and further I simply print that. So now it show me the result in square meter unit, how much area we can get for that area in urban 2021. And then we can get this type of result. It's for the square meter unit. So for the we just simply convert in square kilometer. So for that same process, just take a variable urban area. I put that this type of variable name, and it's a number. Okay, and this number is stored in this variable. So I simply use our e.number and call this variable name. Okay, and you can see we can get the keyword classification. Okay, so I want to get this number. I got this number from this keyword classification. So for that, put here the get classification, basically this name classification. And further, I want to convert into a square kilometer. So divide into this value, 1 is 6. Then you can get the result square kilometer. And when I use the round function, then we can get only for the integer value. Okay, we can get only for the round figure. So just further, I print that. So simply print. We find out 75 square kilometer area in urban in 2021. Okay, so now let's check about that in 1991, how much area. So in this time, same process we try to apply for the 1991. We calculate the how much area for the urban. Same process we try to apply. So for that, what we can do, first of all, you can see this is the land use land cover map 1991. This is the map. So for that, we are just taking same variable. Suppose I put the variable name is the build up area 991, and further I simply call the value. You can see the build up area value is the 1. Okay, so just put here the equal to 1, and for the same process we try to apply in here. I want to show only for the build up area in 991. So now click to the run. In this time, it show the urban or build up area only for the 1991. Okay, so you can see it show only for the urban area in here. Okay, and it's this result show about the 1991. Okay, and you can see this result for 2021. Okay, and a lot of urban area will be increased in here. So we can get this region only for the urban area. Okay, so then click on here, you can see lot of urban area will be increased. Urban expansion, you can see we can get this type of, or urban explorer. This is the other side we can get.
Hello, sir. May I ask a question
Yeah,
now?
Yeah, please.
This is the past. We can assess the difference between any two classes. Is it possible we can predict for the future? For example, in last 10 years, it is happening like 10%. So in the future, what the prediction will be?
Yeah, it also possible. Suppose you want to predict what the happen for the future. So for that, we need to consider some factor. Okay, some factor, formal factor and informal factor we have to make, because urban growth prediction, it depends a lot of things. Suppose one is that elevation, okay, as well as also another is that suppose you want to work for that, suppose density of the population, it's the another factor, as well as there the other factor. Actually, this type of factor we also consider about that.
So we have to add all these factors in Google Earth Engine during this calculation.
Yes,
so
yes.
In Google Earth Engine, okay.
Yes.
Okay.
Okay, so I will show you the one code. Just a minute. So just a minute, because actually it's on another advanced online training for the future prediction. So I'll randomly show you the code, how it will work. I'll show you that. Just a minute.
Okay.
Then you can easily get it.
Yes. Maybe we will join that one also.
Okay.
For the future prediction. Yes, thank you.
So basically, it's another. So I'll show you that for the future prediction. How it will work.
But I did see your this course that you are also offering this course for the future. So maybe in future you will start this one.
Yes, yes. Basically, we have also another 15 days online training program. So basically, after completing the beginners part, anyone interested that they can also join our 15 days online training program. And in this
Okay.
online training program, we try to complete that. There's a lot of analysis only for the analysis. So how we can easily work for the different types of analysis, such as how we can apply the Rusli model or different types of model. We try to discuss only for the model, how we can develop this type of model in Google Earth Engine platform. Okay.
Okay. So please share with us the outlines.
Okay.
Maybe
So I
they should
will I
not.
will send you all of course details for the 15 days. After
Yeah, yes,
completing
yes.
this, then you can easily
So
get
please
it.
you can continue with the today lecture. No problem. No problem. Thank you so much.
Okay. 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 I'll just show you just. Okay, so basically here you can see in this time first I show you that factor, what is the factor we need for that. So in this time we need to do this type of things. Okay. Okay, it's our classification result. Okay, suppose 2023 13 3 13 23, can we predict suppose 2033. Just suppose in this time you can see here, first of all you have to import your land use land cover data. One is the 2023, suppose 2023 13 13 and 2023, and further you also need some other factors such as distance to river, distance to road, or we need the slope data, hillshade data, aspect data, as well as the population density. So all of factor we simply import it in here, and further we are just applying that the classic regression about that. Okay, and then we can easily get, if you want you also more factor. Okay, so basically when you want to add the more factor, then we also get the more better result for the prediction. Okay, so in this time if you want to go the further, then you can easily get a lot of things about that you can know. Let we continue from
Many
it.
thanks, sir. Many thanks for this. Thank
Okay,
you.
okay. So in this time, we talk about, in this time, we just simply take this type of R1 for 1991. We can get this type of result in here, and 2021 we can get this type of result in here. So now I want to calculate the how much area for that same process. We calculate the area, and also calculate the area for R1 area 1991. We just use the same code. Okay, and then we are just calculate the area in square kilometer. I can click to the run. So now it show the result for urban area in 1991. So pin that how much area for 1991. We find out only for the 5 square kilometer area in 1991 for the urban or built up area, and we can get that total urban area in 2021. We can get that 75 square kilometer area. So 70 square kilometer area increased between this two time period 1991 to 2023 or 21. This time period 70 square kilometer area is increased for the urban. So here you can see we can get only for this urban, it only for the 5 square kilometer area we can get, but in 2021 we find out the total urban look like that, 75 square kilometer area. Okay, so now I want to make the change detection only for the one class. Suppose where there is urban is available in 1991 and urban is also available for this place 2021. So if there is no change, suppose you can see here this place is urban is available, okay, and 2021 is also available for this urban. We can look this place, we can get that this place is also available for this urban. Okay, so this place there is no change, but other place you can see this type of place is urban is also increased. Okay, new place, this type of place is increased, and how much increase? We find out that 70 square kilometer. Okay, because we have already the 5 square kilometer is available for this study area, so this is our 5 square kilometer area, we can get it. And now 2021 it increased that 70 square kilometers, so that's why we find out that 75 square kilometer area in 2021. Okay, so now I find out the change detection between the one class only for the urban. So for change detection, basically just I take a variable, suppose urban changed map, we simply call the before class and after class. After class and before class, simply put the build up area 2021, okay, which is 75 square kilometer, and subtract with build up area 1991, which is 5 square kilometer, and further we simply show this result in here. So just click to the run. In this time I find out the yellow color, it means that there is no change. Okay, it's unchanged, and only red color identify about the changed area. You can see I just simply open this layer, so and okay, and also open the satellite view, then we will some more we can get. Okay, so also uncheck the levels. So here you can see it was vegetation, this type of place was a vegetation. More, but I just simply open the LULC map, you can get the better view about that. You can see. Okay, so now okay, so in this time you can see here this type of place in 2021 we find out the build up, okay, but it was a vegetation. Okay, so this type of vegetation loss, okay, and convert it built the new urban area or build up area. Okay, so you can see this type of things. When I get that two layer at the same time, we can easily get the idea. Here you can see, so you can see it show that vegetation, and this vegetation now in 2021 this type of vegetation show as a build up area. Okay, in 2021. Okay, it consider only for that vegetation, not other class. That was this type of vegetation convert into other class. Mainly this type of vegetation loss. It can be converted into build up area, or it can be convert into water body or barren land or anything. But this type of vegetation loss between this time period 1991 to 2021, this time period we can get this type of result. As you can see, this is the map about that, and I also open this map. Here you can see when I overlay these two map at the same time, then it also more better understand about that. Here you can see. Okay. So this type of red color in 2021, it show the 2021 map LULC, and it show about that vegetation loss in vegetation loss. Okay. So it show the vegetation in year of 1991. Okay. So this type of vegetation convert into other class. You can see now in this time we can find out that build up red color you can see, or barren land. Okay, you can see it change. Okay, but in 1991 when I open that LULC 91, then we can get that vegetation also in here. You can see it show the vegetation. Okay, so this type of vegetation convert into other class in 1981, and you can see it show the vegetation. Okay, vegetation, but 2021 when I open and also open this layer, then we can get, okay, this type of area, this type of vegetation convert into in build up or other class in here. So now we want to calculate how much area, how much vegetation area convert into other class. So the same process we calculate the area. So just we take a variable area e.image.pixel area multiply with these things. Basically this is the, it is stored only for the vegetation loss. Okay, vegetation to other class, and further we are just calculate the area, how much area convert into other class for vegetation. Just use it, and further call the area reduce region. I calculate the total area, so use the sum, then put here the print the area, then we convert the area in square kilometer. So just use that square kilometer and print the square kilometer area unit. So now further click to the run. So in this time it show you the result how much vegetation loss between this time period 1991 to 2021. Okay, we find out this type of 34 square kilometer vegetation area loss between this time period 1991 to 2021. Okay. So in this time I talk about only for the vegetation. If you want to also check suppose how much barren land convert into other class, so for that simply use here the 4. Okay, because 4 is the barren land to other class. How much water body, just put here the 1, then we can get the result for the water, how much water convert to other class. So when you want to use that your different project, you are just use the same concept, and then you can do the different types of analysis. Right? So now let's check about that. In this time, suppose I want to convert this type of vegetation area. So this type of vegetation area I want to convert into polygon. Okay, suppose I want to create the shape file. Suppose you can see I create this type of, it's a raster format. So now this type of things I want to convert as a polygon. So that's why I can easily make the shape file or KML file. So this shape file I can also use for my other purpose. Okay, so in this time I will show you that how we can easily convert raster to vector conversion. So it's a raster imagery or tip format. So now this tip format, all of vegetation change area I want to convert as a polygon. Okay, shape file or KML or KMZ file. So in this we talk about the raster to vector conversion. So for that it's very easy, just we are use this function mainly reduce to vector. Okay, so just take a variable, I put the variable suppose area base, you can put any name, I call the vegetation to other class. So basically it stored, this variable stored this map. Okay, this raster format vegetation loss map is stored in this variable. Okay, so basically this is my variable, you can see this is my variable. Okay, this variable is stored that only for the vegetation to other class. Okay, so now I want to convert it as a vector. So for that I just simply use a function reduce to vector. Not only for this data set, when you want to convert any raster to vector format, then simply use the reduce to vector vectors. Okay, then reducer, in this time I want to count every pixel, so that's why use the e.reducer count every function, and geometry is your boundary shape file, scale is the resolution of your satellite imagery, 30 meter I put in here. And further I want to add the layer about that. So now I can see what happened, I just add this layer. So now it shows as a polygon. Okay, all of vegetation loss area show as a polygon or shape file. So now it's converted into raster to vector. So just working. So now I can see we can get all of things as a polygon. Basically, this type of polygon was vegetation, but present time it set up, it build up or also other class. Okay, not vegetation. So this type of place, this type of boundary, you can see this type of boundary was vegetation. Okay, but now present time in 2021 we find out this type of boundary or polygon there is no vegetation. Okay, so it is a vegetation lost place. We can lose the vegetation this from this type of region. Okay, from this type of region we lost our vegetation between these two time periods. So it shows as a polygon. We can easily get this type of polygon from here. So this type of polygon lost the vegetation from here. So now I want to export it as a shape file or KML file. So for that we are just use the code. First of all, these things we convert as a feature collection. So just use the function e.feature collection and call this area veg area. And now I want to export as a shape file. So just use the code from here. So now we can get the result collection. I call this collection col. I put the description any name, then folder G shape file. Then click to the run. Now our task tab will be running. And from here we can easily download the shape file or KML or KMZ file for different types of analysis. So here you can see the task tab. Click on here. Now we can simply click on here. You can easily download the data in a shape file. Okay. Further, you can easily use it for the different types of visualization data. So basically, this is the overall change detection. I will try to explain. Okay, and I also send you this code. You also try to practice. Further, face any problem, then you can also mark me. Okay. So now, question, please. Yeah. Please.
Yeah. That's one thing. When you are selecting the signature for the machine for the supervised classification, okay. Like in normal, Google, like in ADAS or something, you can go to previous year images. Let's say for the 2000, okay. I'm selecting a signature, okay, year 2000. So for selecting that, I need to go to the Google map of 2000. Okay.
Yeah.
So can you do that in Google this Earth region?
No.
So how did you select the signature for the previous year?
Previous year, mainly we take the signature from that satellite imagery.
No, my question is, let's suppose there is, for ground truthing, I want to select the images. Okay, want to check it. Let's suppose for this year, I selected a few signatures from the Google Map available. Okay, but in the previous year, won't be difficult to select that because we don't have the Google images for that.
Okay, so in this time you talk about the signature for that previous time, how we can easily collect for that. Okay, in Google Earth. Okay, so in this time we have to use the Google Earth Pro. Okay, suppose if you want to check it, then you can simply go to the Google Earth Pro, and in Google Earth Pro we can also get that annual satellite imagery also. Mainly Google Earth Pro for the high resolution with that. For collecting the signature or other things, suppose, okay, let me check here. Google Earth Pro is available or not. It also possible. Suppose basically in Google Earth Pro we can easily get it all of high resolution satellite imagery from here. If not installed in my system in here, and we also get that annual imagery also from here. Just a minute, I simply open the web version.
So it won't be wise like to have signatures for different years, different.
And mainly, why you take the signature for the previous time?
because let's suppose there will be certain places, let's say in 2000, which will be changed to a different class. So
Yeah.
having the signatures from the same uh, year, it will be it will prevent any error.
So basically, we need the signature for build a data set. Okay.
Yeah.
And now we want to use the satellite imagery and create the signature. Suppose I was just open the satellite image for 1991 and then take the signature. Basically, pixel or training sample from here.
Yeah. So the question is, would it be better to use image of that particular year, select them, make a data set for that particular year, and when we have a new image, new year, we have the year of that.
Yeah.
Are you getting my question?
Okay, so basically in this time here you can see when I want to make the land use land cover classification map, I take the two time signature. One time
can see.
I collect the training sample from my satellite imagery 1981. Okay, from my satellite imagery 1981. Suppose here you can see for the classification we are just take the training sample from 1981. Okay, suppose you can see this is my image. Okay,
Okay.
Landsat image. This is the Landsat image for 1981. Okay.
Okay.
So I want to make the classification. So in this time I need
For
the
19.
signature. For the signature, I just simply use this satellite imagery, which image I want to collect from that Landsat. Okay, and then you can see this is the imagery Landsat 1981. And now further, I want to take the training sample from this images for my year of 1991.
Okay.
Okay, and further when I need this a new image, suppose I want to classify this imagery using all of sample, it's done.
Yeah.
After that, I simply open my new another image, suppose 2021.
Yeah.
Okay,
Yeah.
and then I take again all of training sample from the 2021. Suppose here you can see water 2021. I take the water body, I find out the satellite imagery.
Okay, I got it.
Yeah.
I got that part, but it's not possible to go back in the Google images, right? Like, okay, just in the Google Pro, we can move to the previous year.
Yeah.
So it's not possible.
Yeah, it's this time it's not possible because it's the Google Earth engine. So another. So Google Earth Pro already provide this type of facilities. So that's why I think they are not
That's
added
fine,
things in here. Yeah.
just one more thing, we can download the Google Earth in Earth Engine in desktop.
No, it's a cloud-based platform. Cloud-based platform. Mainly, we are just cloudly run it. Okay.
Okay. So can't we connect this with ArcGIS Pro and something like that?
Yeah, ArcGIS Pro is also possible to that. Suppose ArcGIS Pro, for the paid version ArcGIS Pro, is also possible to connect with the Google Earth engine and work with that.
Okay, could you say share a link possible?
Okay, I'll also share the link about that. No problem about
Thank
that.
you.
How you can
Thank
connect about that ArcGIS Pro with the Google Earth engine. It also possible to that.
Thank you. Thank you.
Okay. Okay, so any question about this regarding this coding?
Sir, I have one question.
Yeah, please.
Sir, if I want to download for example, if so some values I want to download from satellite image, and I want to process it in Python to forecast those values.
Okay.
So
Yeah.
how many values can we download from satellite images in Google Earth, sir?
So values mainly it's a point value or polygon.
Point value, sir. Point value.
Okay, so there is no limitation. So I think you can easily download that lot of points. More than I think more than 5,000 or below the 5,000 is also possible. Okay, it was a question. No problem.
Okay,
Okay, so our class not finished yet. So I have to talk about another topic also. So regarding this topic, anyone any question? Then we back to the problem solving class. Yeah. Okay, this topic have any question for the full code? Okay, so you try and find out when you face any problem, then you also knock me. Okay, so now we talk about that another change detection, which is NDVI change detection. So basically NDVI, we already know about the NDVI, how we can calculate the NDVI. So basically NDVI, it's calculated by near infrared band minus red band, divided by near infrared plus red band. So in this time, we are also calculate the NDVI, and further we try to calculate the NDVI change detection, and also calculated the vegetation loss, how much vegetation loss will be. So I run the code again and try to explain on the one. So here you can see we can get this is one kind of vegetation layer, 2015 to 2020. Okay, this is the one NDVI map, and these are 2015 and 2020. Okay, we can get the two map, two NDVI map. So how we can create that? Just we simply import the image collection, proper atmospheric image collection, and further we simply filter this image collection. Okay, and then we are just use the you can see near minus subtract with red band divided by near plus red band. Okay, and what is the near? Near mainly B5 band, and what is the red? Red mainly B4 band. Okay, I already stored this variable near and red, and further I simply put my equation and rename it as the NDVI. So now I can easily got this NDVI map 2015, and I also display this image. I can get this type of map. Okay, NDVI image 2015 look like that. Okay, and further I want to create the another map 2020. So for that we simply take the image 2020. Okay, and in this time short and fast, basically I already explained this function short and fast. Okay, so in this time it take only for the one image, which image is the lowest cloud cover image. Okay, and then we just use the image and calculate the NDVI. Same process, we calculate the NDVI for 2021 22. Okay, and now we display the result. We can get this type of result for NDVI 2021 22. Okay, so now I want to calculate the change detection. In this time we calculate the change detection two way. One way is that we are just make the class. Suppose I just calculate the class, make the classification of NDVI, and then make the change detection. Okay, suppose you can see for land use land cover change detection, this like this. Suppose you can see we are just simply make some class of land use land cover classification. Okay, water build-up, vegetation, and others. So in this time, suppose I want to create some class of NDVI based on their thresholding value, mainly their pixel value. Okay, so let's go how to easily calculate the NDVI thresholding value. For doing these things, I just simply consider the total 5 class. Okay, so just I make here you can see I just take a variable NDVI class 2020. I just e.image 0 and map without classification. Now I want to put a thresholding value and calculate the area. Okay, suppose I want to check greater than 0.4 all of vegetation. Okay, from the changed map I want to change greater than 0.4 how much vegetation. Suppose 0.4 this type of pixel value, how much area have only for the 0.4. Okay, so I have to show this result. I was click to the run. In this time it show about the vegetation 0.4, and this vegetation will be changed between this two time period 2015 to 2020. This time it will be changed. Okay, so here you can see we can get this type of vegetation. Okay, so basically in this time this type of vegetation changed between two time period 2015 to 2020. Okay, and I put here the thresholding value 0.4. It can be defined if you can check the 0.5 or 0.6. Mainly 0.4 is the vegetation, 0.5, 6, 7, 8. It's the more dense vegetation indicating about that. So in this time when I put the 0.4, I can get this type of vegetation area changed. Okay, and if you want to also open the changed map, suppose I just simply open it, the changed map. So also you can see about that. It will show about that. Okay, so you can see it show the red color. You can see behind this scene we can get the red color. Okay, and red color identify about the changed. Okay, and in this time we consider only for that greater than 0.4. Okay, where if I find out that 0.4, this type of pixel of vegetation, I want to consider only for this area. So that's why you can find out only for this area where have 0.4 pixel of NDVI, but other area it not considered because other area have also low NDVI value. Okay, it can be 0.2 or 0.1, this type of value. So in this time I put at the 0.4. That's why it show the result only for this area where have we find out the 0.4 of NDVI value or greater than 0.4 all of pixel, greater than 0.4 of all of pixel. So in this time we can see it also, we can get the similar things also. Basically when I calculate the change, this type of red color identify about the changed area, and when I consider the 0.4, then I can easily find out that this type of vegetation 0.4 greater than 0.4 pixel of NDVI, this type of area vegetation was changed between this time period 2015 to 2020. Okay, so it's one kind of vegetation loss between this 2015 to 2020. Okay, so now we are just calculating the area, how much area about that. So just use the same process doing these things. Suppose pixel area, I call the vegetation, multiply with this function a.image by pixel area, and further I just simply put the total area. Same process, just simply put in here. Okay, and print the area. This area I want to convert into square kilometer, so just put here the square kilometer, and then further we check the result. What about the click. So now it show about that how much vegetation will be lost between this time period 2015 to 2020 and greater than 0.4. Okay, this pixel. So this is the process without classification. We are just put a thresholding value and calculate and make the change detection area. So here you can see now it show the result in here. How much area we can get? The 124 square kilometer area. So this is the result. This type of you can see this type of pixel this type of area was vegetation, and the total area is that 124 square kilometer area. It changed between this time year of 2015 to 2020. So in this time we are not put any kind of classification, just we set the thresholding value and then calculate the changed area of vegetation. Not only for that, you can this approach you can also apply for the any other indices in NDVI or EVI or SAVI, anything you can do the same approach about that. Okay, so anyone in question you can ask me. Okay, anyone in question? Or any doubt?
Sir, you explain once again the
Which
last
one?
part, sir.
Okay, let me explain. Okay, so in this time we are just make the change detection without classification. In this time we are not put any class, just I simply call the NDVI map 2015 and 2020, then subtract these things. Okay, and show the changed map. So here you can see I just simply show the changed map. I got this type of changed map. Okay, and from the changed map I choose only for pixel of NDVI which are greater than 0.4. Okay, you can say I simply call the changed and choose greater than 0.4 all of pixel and self marks. Basically in this time marking the self, and we can get this type of place. This type of place show as a vegetation, and this vegetation is greater than 0.4 pixel NDVI pixel value. So you can get this type of changed 0.4 because you can see when I subtract these two things, it already stored the changed. Okay, and I consider only for the changed area greater than 0.4, then I can got this type of vegetation, this type of 0.4 pixel, this type of vegetation will be changed. Okay, and now if you want to open this changed map, suppose I simply open this map, also you can see it also show about that. Okay, so basically it show the overall changed. I already calculate in here, you can see I already calculate the overall changed after classification. Just simply subtract these two things, and we also get this type of red color. Basically you can see this map, this type of red color show about the changed, and white color show about the unchanged area. Okay, but it all of pixel of NDVI. Okay, but in this time in this time I just simply put only for the greater than 0.4, and I find out this type of place have a 0.4 pixel of vegetation of NDVI value, and now it will be changed, okay, between this two prime, because I subtract these two things in here. So now it will be changed, and further we calculate the area, how much vegetation will be changed in here. In this time here you can see, suppose I just put here that 0.2, okay. So in this time also all of pixel of NDVI greater than 0.2 consider and calculate this area, changed area. Suppose click to the run. In this time we can get this type of map. This map including all of NDVI pixel which are greater than 0.2, greater than 0.2, all of pixel in this time considered, and you can see you can get the 469 square kilometer area will be changed, and you can see the changed map. Suppose I just try to open this layer. Okay, you can see in this time it consider this type of green pixel, okay. So this type of pixel will be changed. Just I simply open that. All of pixel which are greater than 0.2 of NDVI. You can see this type of vegetation changed between these two time period. And also you can simply open this our overall changed map. You can see we can get the red color, okay. So you can see there is no pixel, white color pixel we cannot find out because white color is not changed. Red color is only identified for the changed area, overall all of classes change area. And when I just put a specific value, suppose greater than 0.2, so now it showed only for this changed area where I have greater than 0.2 NDVI pixel. Okay, so now it consider the more NDVI value and also show about the more NDVI vegetation. Okay, because in this time we put at the greater than 0.2 consider in here.
Thank you, sir.
Okay. Okay, so any question?
Sir, can you please upload the fifth D lecture also?
Yeah, okay. So I also upload the same at the same time two video. Then you can
Yeah.
No, I will upload it. No problem. I will upload.
So thank you so much. Yeah, no question.
You can see here we can get this. This is the base map of 2015 NDVI image, and you can see we can get that. Suppose you can see it show the vegetation in here, okay, and also you can get that changed map is also about the vegetation, okay. 2015 was a vegetation. You can see it's a vegetation, but here you can see when I open that image 2020, in this time we can get it. There is no this place. You can see it's also changed, and when I open my changed map, also you can see the difference between these two things. You can see, okay. So you can see now 2020 there is no vegetation in this place. You can see just I open it, we can get this type of things. Also you can see this is this place also you can see there is no vegetation. So it will be changed within two time from year of 2015 to 2020. We can get the changed this place. Also you can see this place there is no vegetation in 2020, but yeah, it was vegetation in 2015. So it changed this two time. Okay. So basically this is the process to make the change detection. You also try for other area or other your other project. Okay. This type of code you also try to use for the other project and do this type of analysis. And further when you face any problem, you can get this support, no problem. Okay. Okay. So anyone any question? Okay, so can you create the GIF image of change detect? Yeah, so yeah, so it also possible to create the animation about that. Okay, so basically I will send you the another advanced online training program. For that we including all of part for creating the animation or other things. You can easily, if you join, you can easily get this type of things. Okay, so I'll also share our full 15 days online training program also. And before that, you try to complete all of things properly from the this 7 days online training program. So basically, if you want to properly, if you want to learn all of those things for 7 days online training program, then you can easily learn every code. Okay. So actually, in the online or in the online platform, you can find a lot of code. But when you want to learn how we can easily modify this type of code, you can easily get there are a lot of things you can easily do for your own self. Okay? You can easily do it. So just first of all, you have to learn. You have to know about that how the code will be worked, and then you also need to know about that how we can modify this code and use it. Okay. Then I hope you can easily learn a lot of things and you can easily develop different types of things about that. Okay. Okay. So any question? Okay, so if there is no question, okay, so I will put all of assignment in our Google Classroom. You can simply check all of assignment from the Google Classroom, and then further you can simply put. Basically, in this time you are just make a document in the PDF, and you take the screenshot as well as also paste the code link. Okay, and as a PDF document, and every assignment for every single PDF you try to make. Suppose third number assignment. You can simply monitor the flood area using thresholding technique and calculate the flood area of any region. Okay, just simply you do these things and then make a screenshot and also put your code link. Okay, and you also share your asset. Basically, simply go to the asset tab and then share anyone can read. So that's why when I go to this code link, I can easily find out the show the code. Okay, so you also try for every assignment create the every PDF file. Okay, then simply submit. And PDF file mainly including the figure as a screenshot of your map, as well as also including the code link. Mainly click on the get link button and then paste the link on your figure and make the PDF format and then simply submit in our Google Classroom. Then further, there is no deadline. Okay? There is no deadline. When you take the time, you can learn and then submit that. Then you also get the certificate from us, and then you can use it. Okay, so I will put all of assignment as soon as possible for this this batch. Then you can easily do it, and further face any problem, then you can easily get this solution. No problem. Okay, so any question?
Yes, I have a question.
Yeah, please.
No, general question. It's not related to what you are presenting, but I want to know if there is satellite data about hydrological data, like the discharges, because most of the data we have is about the weather. But I want to know if there are data for discharges, like a flow of a river, if a satellite can detect it.
Okay, so basically this type of we can get the lot of data set from the Google Earth Engine data catalog. Suppose suppose hydrological data, different types of hydrological data, as well as we also make the different types of suppose analysis, suppose water balance, or also river flow of water, or also make the stream water, as well as also make the suppose there are a lot of things you can easily do it. Suppose simply go to the browse data catalog and you can get the lot of data set. Suppose I need for that surface runoff data. Okay, the surface runoff data, we can easily get it, this type of data in Google Earth Engine data catalog, and further we can use this type of data and then we can easily get it. So I simply search here river flow or river network. Simply search there, then you can get the lot of data set, and then you can easily use this type of data. And the same process, suppose filtering, we already discussed a lot of time about the filtering. Suppose you want to work with the hydrosheds, free flowing river networking P1 data. So it's one kind of data which provide you the river flow. Okay, you can see, and this data set you can easily use it. So how we can easily use it? Same process, simply copy this collection and import in your code editor, then import your shapefile boundary which you want to need. So then simply same process. okay, for filtering all of things. And also you can see it also provides some demo code also in here. Suppose you can see it provides some demo code. If you want, you can simply copy this code, then you can easily get the trick result about that. Simply copy and then just open a new code editor. Just simply paste here. And now I run the code, then I can easily get this result for globally. Okay, but the suppose I click the run. So now it shows about that this type of result. You can see the river network or river flow about that. We can get this type of result. But this data I need only for my study area. So what can I do? Suppose I just simply import my study area, or simply from the asset tab, simply import your study area. Or if you want, you can simply draw a rectangle about that or anything. Suppose.
Okay, it is fine because there are many catchment, many watersheds that are unused. So if there is a possibility to have a historical data about flows for modeling purpose, it will be very fine, very helpful.
Yeah. And now I hope now you can easily get any kind of data you try to drive from your own self, and further face any problem regarding any issue. Just before one day, you can mark me. I will give you an appointment for a specific time. Okay, then you can simply join with that, and you can also discuss with this problem or solution about that. Okay, and it continuous learning process. So that's why we're also providing the lifetime teaching support when you face any problem. And I also learn from also all of people. Okay, when you face the problem, I also try to do that, and I also learn from yourself also. Okay, so when you face any problem regarding any issue, you can simply knock me before one day and take your time and then join with and discuss about the solution. Okay, so then that's why you can easily smoothly learn all of those things. Actually, there is no limitation about the learning. Okay, so when you want to learn more things, you can explore the different types of things. Okay, so you try all of people, and then face any problem, then let me know. I also try to support all time, no problem.
Okay.
Okay, today is no more. And further face any problem anyone, just let me know, then I will give you the lifetime teaching support. And there is no limitation about that deadline for the submission of assignment. When you do completely all of these things, you simply put this assignment, no problem. But when you do the assignment, you face a lot of problem, because as a beginners, when you do that, you can face a lot of problem. So that's why you can knock me for your assignment. When you face any problem, then I also guide you also for the completing the assignment, no problem. Okay.
Okay, it is fine.
Okay, thank you. Okay, so today is no more. Thank you for everyone for joining. Okay.
Thank you, sir.
Okay, fine. Okay.
Thank you. We have learned a lot of.
Okay, thank you. Thank you.
Thank you, sir.